In today's lesson, 6.1, we are going to learn how to convert radical expressions to exponential expressions. Actually take them both ways, from radical to exponential and exponential back to radical. So take a look at a couple warm-up questions that you should be able to do without your calculator. Square root of 121, we all should know, is 11. Number 2, those students tend to forget their Algebra 1 exponent properties. The answer here is not going to be a negative number. What you need to look at and remember is that when you have a negative exponent, you need to change that exponent so that it's a positive number. And we do that by putting it in the denominator. We're going to take the 5 to the negative 2, throw that in the denominator of a fraction, 1 over 5 to the positive 2. So putting the 5 to the negative 2 in the denominator changes your exponent to a positive 2, and you can simplify that to 1 over 25. The third warm-up is very similar to what you've done in the last chapter, so let's just move forward. So again, our goal today is to write a radical expression into an exponential expression. So just remember some of the things you've learned from pre-algebra classes, your Algebra 1 course. 3 squared is 9, and we know that's true because the square root of 9 is 3. 2 cubed is 8, and we know that because the cube root of 8 is 2. So take a look at those pairs and see how they work together. If you look over here, the number inside the little hook, so to speak, of this radical, we don't even need to write. If there's nothing there, we know that it's a 2. Here we have to put a 3 in place to indicate that we're taking a cube root. So ignoring the words up at the top of the page for now, let's look at how we would solve this equation, which is something you already know how to do. In essence, think of what's the opposite of cubing? Cube rooting. So let's cube root the left side and cube root the right side. The cubing and the cube root cancel each other out. So x is going to be equal to the cube root of 64. Which hopefully you're starting to get familiar with some of your perfect cubes. 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 squared is 125. Those are some you should just easily recognize. It'll make your life a lot easier. So as we look at the wording up here, up at the top, take a look now at this expression. B to the n is equal to a. When you solve that, it's the nth. It would be the nth root of a, exactly what we did in our example. So as we begin to evaluate roots, the 6th root of 64, if you want to write that in exponential notation, is 64 to the 1/6 power. The 4th root of 5 is written as 5 to the 1/4 power. So we've just taken a radical expression and converted it to an exponential expression, as our guideline here tells us. When we want to convert a nth root, it's a to the 1 over n. This also works when you have a fraction where the numerator is not 1. Let's say it's some variable m, or in this case, let's look at the number example, 16 to the 3/2. We know that 2, that denominator, is what's going to go inside of the hook. That's our index number. We're taking a second root. But 3 remains an exponent. The 3 can be inside of the parentheses with the 16 underneath the radical, or it can be outside of the parentheses. And in this case, we would want to leave it on the outside. I would not want to have to take 16 to the 3rd power if indeed I pulled that 3 underneath the radical. I don't know what 16 to the 3rd power is off the top of my head, but I can square root 16. That would give me 4, so I'd be taking 4 cubed, which is 64. This idea also works with a negative exponent. Remember, with a negative exponent, we throw that down in the denominator. Take that negative exponent and we throw that entire term in the denominator and your exponent becomes positive. And then we can continue on with our rules for changing a exponential notation into radical notation. And this works in this case as long as a does not equal 0. We can't have 0 in the denominator of a fraction. Let's see how it will work with a number example. So when I have 32 to the negative 3/5 power, my root is going to be 5. It's going to be a 5th root of 32 to the 3rd power. But we have a negative exponent, so everything has to be thrown down in the denominator. So let's follow the steps here. I throw my entire expression in the denominator. So now I have 1 over 32 to the positive 3/5. I'll make 5 my root, the 5th root of 32 to the 3rd power. That's all in my denominator. I don't know what 32 to the 3rd power is, so I'm going to assess first what the 5th root of 32 is, and that's 2. Now I can take 2 to the 3rd power. My simplified answer would be 1/8. A couple examples that you can work on solving simply by taking, in this case, the left side and raise it to the 3, not to the 3/2 inverse. You want to take the left side to the 2/3 power and take the right side to the 2/3 power and simplify from there. In this problem, you would raise the left side to the 5/2 power and do the same thing on the right side to simplify these expressions.